Welcome, everyone. Welcome to the blockchain class and your applied project. Good to see you all. So we have 29 people in the class. There is a second class camera that I use for my presentation slides. So that's what class camera 2 is, so that I can also look at the participants and read the chat at the same time. So you'll see the agenda. First, we're just going to talk about Zoom to make sure that everyone can navigate it properly. I do encourage everyone to ask lots of questions. A lot of people get very confused with blockchain, even though it's actually not that hard when we dig into the details. I'll give you an easy explanation of how blockchain works. Then I'll give you a full-featured applied project that I actually did in China last summer. Then I'll talk about how to get an A. And then lastly, everyone's going to be confused about something with blockchain, so I'm going to ask you to raise your hands and ask questions. I can also stay later after our 1:30. Voluntary, so it does not count. If you have to leave at 1:30, that's fine. So let's start off with making sure that everyone understands how to use Zoom. So could you please go to the participants box, and on the bottom left, would everyone raise their hand and keep your hand up? Looks like almost everybody. If you have any trouble finding that, just open up your mic and I'll walk you through it. So in the participants box on the bottom left, you should see the raised hand button. So if everyone could click that, keep your hand up. So Gargi, Idris, Yunsi, Kadang, if you could all raise your hands. If you can't find it, just open up your mic. There's also tutorials in Canvas, but I figure it will go a little bit faster if we just get this knocked out right now. Okay, so I'm going to clear that out. Now for voting, we're also going to be using the yes button. So that's near the raise hand. So if everyone could click the yes button or the no button, doesn't matter. So this will help you with your class participation grades. Okay, then I also put a little mini assignment into the chat. If everyone could put in what their interest in blockchain is. I'm going to be reading this later. I'll take a look at some of these now. What your interest in blockchain is, what your major is, anything that you'd like me to know would be great. And before we begin the lecture, feel free to raise a hand if you have any questions that you need taken care of right now. Okay, also, I did get an email from a student about the final project. It looks like the final project description in Canvas is a mistake. It was copy-pasted from the last Nano course. So I'm going to be walking through what the final applied project is, and we're going to be correcting that probably today as soon as possible. Okay. So raise your hand if you can see these slides. Okay, let's begin. So, for starters, what's blockchain? A lot of people are confused by it. It's actually not that complicated because there's a lot of new terms that are actually terms that we're really familiar with. But in a nutshell, blockchain is really just a fancy database. That's basically what it is. And we're going to be digging through why is it so fancy and why is it better and different than the traditional database that we're used to. So what I like to do is give people an analogy, and I encourage you during the class, outside of class time, go to a friend or your mom or dad or someone who really isn't technologically oriented and try to explain to them this example or use your own analogy. And I see two hands up. Before I dig into it, let me just make sure everyone's taken care of. Gargi, hi. And let me know if I'm pronouncing your name right.
Hi, Michael. Yes, that's correct.
Okay, hi, welcome.
Thank you.
And Yiming, I see your hand is up.
No, I raised it
Oh, the
Previous.
reason for something.
I couldn't raise it before.
Okay, good, excellent. Well, we got that taken care of.
Yeah.
Yiming, hi, would you like to open up your mic and say hello? Okay, so if there's anything that anybody needs during the
Yes, I
presentation.
can. Hello.
Hi, Yiming.
Hello. Yeah. Hi. Here.
Can you hear and see
Can
the
you hear
slides?
me? Oh yeah. I already did it.
Okay, are we ready for the lecture, or is there something I can help you with? We're good? Okay, during these slides, if there's any questions that you have, since this is cumulative information, please raise a hand. I'll stop and I'll answer any questions that you have. Since it is cumulative, it's really important not to get left behind, so please raise a hand. I really encourage people to do that. It also helps with class participation. So basically, to give you an analogy, let's take a look at a library. And most people are familiar with libraries. A lot of us grew up with them in our own town. And if we look at libraries a different way, it's really a centralized database. It's centralized because in this example, there's only one. And it's a database because the data is in the form of books and they're held in the library. So we can just kind of look at the library as a centralized database. But there's problems with libraries. One is that the data is vulnerable. And you could have fires, you could have floods, someone could steal a book, someone could rip a page out of a book, someone could put a fake book into the library. So this is something that we want to get rid of, the vulnerability of the data. So here's a way that we can do it. We could have multiple branch libraries around the town where now if the library in the Northeast burns down, well, that's okay. We basically have 5 other libraries that would have data. If we have a flood in the southwest of town, the rest of the libraries are still going to be surviving. So the data, since it's been replicated and effectively copy-pasted elsewhere, it could help with some of the data vulnerability. However, it's not really perfect because maybe one branch library had a book that the others didn't because they're not actually mirror images of each other. They're close, but they're not actually mirror images because not every branch library has the exact same data inside of it. Now, what if we electronically connected all of the libraries? So that would help with mirroring where what's in the Northeast is going to be in the Southwest. Also, notice how there's no longer a main library. This is where people have a really hard time with blockchain in that there is no longer a centralized database. It's all basically branch libraries. Now, we're going to turn this into a blockchain, and there's 5 components to a blockchain. Number 1 is that we took away the central database. That's where the word decentralized comes from. So decentralized just means that you're actually missing something. So you're missing the main library. There is no pure source that you can go to for reference because everything is the same. Number 2 is that they're synchronized. So whenever something happens in the Northeast branch, the same thing's going to happen in the Southwest branch. If a new book comes in, they all get the new book. Also, if a book is taken out, it gets taken out from all of those libraries because they are synchronized, which also means that they're redundant, meaning everything is the same no matter where you go. Number 4 is it's immutable, meaning you can't change the data. So now the data, the books, are no longer made out of paper and ink. Look at them as stone tablets, where now we're etching into the stone, so you actually can't change the information on the stone without noticing it. So let's say my birthday is September 7th, someone etches it into the stone and it's incorrect. Well, if I say, well, change it to September 9th, well, you're going to see them scratching out the 7 and putting in the 9. And you can do that to fix errors in blockchain. You can't edit the data and change it like it never happened. You're going to see basically a paper trail or a stone etching trail that originally it was September 7th, then someone came in, scratched it out, and fixed it to the 9th. So people can actually see what's happening, and this helps with the trust. And number 5 is that blockchain originally was meant to be transparent. So public blockchains, and you'll see there's public and private ones, are transparent. in that anyone can walk into the public library system and take a look at all the books on the shelf. So nothing is hidden from anybody. And the two big advantages that a blockchain gives us over a regular database is now we can trust the data more because everything is in stone tablets and you can't just change the data without anybody noticing. People are going to see any changes that are there. Over time, the same data that was there on day one will be there 10 years from now. Also, you have more security in the data in that it is in multiple locations. So let's say someone hacks one of these locations, it's not going to match up with all the others, which is why we could actually have internet voting on the blockchain. Even if someone hacks one of the databases, it's not going to match all the others, and people are going to have a hard time finding all of them. So basically, blockchain is solving two problems. One is trust and one is security. So for your applied projects, we want to use blockchain to solve trust and security problems in whatever your project's going to be. So this blank screen is for people to raise their hand and ask any questions now before we go into an actual case study. So is there anything about the basic format of how blockchain works that is confusing at all? Raise your hand if there's any confusion. Okay. This is going to be part of your final project. It's the blockchain decision path. And what is important about this is that we need to get affirmative answers to all 7 of these questions, because a lot of times you don't actually need a blockchain. And this is something that you'll be learning in the class, that blockchain is very hyped up, it's very faddish, it's very in vogue right now, but a lot of people don't actually need it. So let's walk through the decision path. Number 1 is, do you need to have a shared common database? So are other people going to be taking a look at that? So if the answer is yes, you go to number 2. Do you have multiple parties involved? If it's just you with your startup and no one's ever going to look at this data besides you, then you just need a database. You don't actually need to have a blockchain, because a blockchain, again, is a fancy database that helps with trust and security. If it's just you, you're going to be trusting the data and you can secure it without going to the blockchain. So number 3 is, are you going to have parties involved that may have conflicting incentives or they're not trusted? So blockchain is actually the engine that makes Bitcoin work, which is pretty much what most people know about blockchain. Blockchain is not Bitcoin. Bitcoin is a cryptocurrency, and the accounting system, the operational engine that makes Bitcoin work, is blockchain. Blockchain is the engine under Bitcoin. Now, why is blockchain good for Bitcoin? Because Bitcoin is basically money, and there are people who have conflicting incentives and are not trusted. There are a lot of people that would like to say, hey, I have 1,000 Bitcoin when I really only have 1 or 2. So if you answer yes to number 3, you go to the next one, that the rules governing the participants are not uniform. This basically means that we need to get everyone on the same page on how the rules operate. So this is basically governance, that we all need everyone following the same rules. Number 5 is, do you need an objective immutable log? Do you need to have something that is accurate, that different people can look at and come to the same conclusions, like a number, 5 is 5 in multiple languages? Does it need to be immutable, where there's no reason that you would want to change it? So you probably wouldn't need a blockchain to write a book, because as you edit this book, you might want to change some sentences in it. So you might not need a blockchain to write a book because you actually do want to change things. And number 6 would be, the rules of the transactions don't change frequently, meaning the rules of the game, the governance that we have in operating this database isn't going to be different. So let's say we have a blockchain for healthcare records. We might say, okay, you have to put in the patient number first to identify them, and then you talk about what their office visit was about. You can't just change that next week and say, well, now just give them some letters as an identifier, or put in their social security number or their date of birth. So you can't change the rules. So the rules really need to be pretty sticky without much changing. And then number 7 is where you can basically veer off. And are the transactions public? So do you want to have everyone in the world seeing all this information? Now, let's say that you want to find out in your public school system, is everyone vaccinated? And let's say it's a concern of yours. You don't want to bring your child into school if everyone's not vaccinated. You want to see that everyone is vaccinated. Otherwise, you don't want to bring your child to school. So that could be a reason to have a public blockchain. But maybe you want to have that information, but it's not going to be anyone's business. So there's some privacy in here. Maybe you just want the blockchain to say, hey, we have a thumbs up that this school is vaccinated, but I'm not actually going to let you look at each individual student's data to see when they got their measles vaccination, when they got the smallpox, because that could be considered private information. So the interesting thing about blockchain is that you can give people permission of what they can and cannot see. Before I move deeper into the lecture, raise your hand if there's any questions on this slide. Rusha, and can you let me know how to pronounce your name correctly?
Yeah, it's Rucha.
Rucha. Hi, Rucha.
Hi. Okay. I'm sorry if I confused earlier. So on the previous slide, we said that for the blockchain, the data needs to be decentralized. Like there is no need to have a centralized database.
Mm-hmm. Yes.
And on the current slide where we are talking about the whole path, the first point says that need for a shared common database. So are these two different things that we're talking about? Because when we say shared common database, so common database could also be a centralized database which is shared between multiple parties within an organization.
Yes, the reason is that you want to make it safer. So let's go back to, just take a look at the image. That imagine that we only had one centralized database, that blank circle in the middle. Mm-hmm. Let's say that was the database, and all the little libraries around it were people that had access to it. Mm-hmm. If you had it set up like that, that's a standard database. Someone could hack it, someone could change the information, maybe change your birth date, and that's a vulnerability in the security. By removing the centralized, basically it's vulnerable because you only have to attack one point. So let's say you're trying to attack the database. Instead of these branch libraries in the circle, you could view them all as centralized databases. So you could say, now I have 6 central databases, but they're in separate areas. So you can't hack them all. You have to hack them one at a time, and you're going to have a hard time finding them all.
Okay, so basically the decision path is if you have a centralized database, then it makes more sense to have blockchain, because then you can use this technology on the individual databases by not combining them together and protect them from hacking and other threats.
Yeah, it's a security measure that if you only have one central database, then a hacker only has to go after that one target.
Got it.
By not having it centralized, now they're moving targets. There's 6. I mean, there could be hundreds, thousands, and it's going to be harder to hack. And even if one gets hacked, you just compare that data to all the others, and you'll see, well, 5 of them all match up, and one of them has different stuff. Then you know something happened here. Plus, you'll see that you can see that the database gets hacked. That's one of the features of blockchain. It's kind of like seeing a smashed window. That when you walk into your home and something's missing, your first note would be, oh, the window was smashed, so you know something happened. And in blockchain, everyone leaves a trail. Okay?
Yeah, got it. Thank you.
Hi. Okay, and David, welcome.
Thank you. I was wondering, could we maybe return to the slide with the blockchain decision tree?
Yep. There we go.
So yeah, my question was about the permissioned blockchain. So there's kind of a private blockchain, but I assume there's still some party kind of governing access to that private blockchain. And does that not kind of undermine the entire concept of a blockchain if someone has centralized authority to govern people's access? How does that work? Because if you want to do something dodgy, couldn't you just cut off the access of everyone else or something like that? In that case.
I'll give you the evolution of how blockchain has come out. Originally, its first version was it's going to be public. Everyone can see everything. And that sounded great. Everyone loved that in the beginning. But then corporations started to look at it and say, okay, we love some of the advantages of it, but there's some disadvantages, and there's the privacy part. So let's say, David, we have your medical records that are on the blockchain, and you like that because if something happens to one of the databases, you've got 5 or 6 others, multiple others to back it up. You don't have to go back in for that x-ray or the colonoscopy or whatever the procedure was, and everyone can remember everything. So we like that, but do you really want, let's say, a nurse that works at the hospital that maybe had a fight with your mom and starts looking at your medical records and says, hey, you know, David had 3 cavities when he was 8 years old. And you're going to say, wait a minute, I like all this record keeping, but I don't want everyone knowing all of my private business. And that's when it evolved into a permissioned database where only certain people could see the data. And this is where we came into solving the problem of privacy. So a public blockchain doesn't have any privacy, and hospitals aren't going to want to use that. So when we came into medical centers wanting to use this for electronic medical records, what they wanted to do is say, well, sometimes we want to share the data with people who are authorized and not with people who are unauthorized. So for example, let's say that you're my dentist. And as my dentist, I want you to take care of me. Well, when you go to the dentist now, they take your blood pressure. They look under your tongue. They do like a quick HIV examination. They're looking for oral cancer. They also want to know, do they have to put on extra expensive material to protect themselves? So if I'm HIV positive or I'm contagious, then you want to know that you have to put on special garb. Now, I want you to take care of my teeth. I don't want you to catch my cold or whatever infectious disease I might have, but I don't want you to know all of my information. I just want you to clean my teeth, and I want you to be okay. But I don't want you to know that I have HIV and I have hepatitis and all this. So what the blockchain could actually do for you as the dentist is not tell you all that information, but it could say, David, when Michael comes into your chair, thumbs down on regular garb, you're going to need to put on the mask and the gloves and like really suit up. Or let's say that I'm healthy as a horse, and you say, hey, you know, Michael's fine and everything's good with him. So you're basically getting to know only what you need to know. Another example would be, let's say that you and I want to go to a bar and we want to have a beer. So they want to make sure that we're 21. So I go up and I show my passport. Well, it does say that I'm over 21, but it also says my full name. You don't need to know my name. When I was born, well, they need to know the year, but not the day, where I was born, and what my passport number was. So this could be identity theft. If you as the bouncer know all this information, all you really need to know is, yeah, Michael can have a beer. So this is where the permission databases came out. What we'll also be taking a look at is amendable or appendable databases that came from Accenture. And what they came up with, and this really bothers the purists, is that they have created a blockchain. We won't spend too much time on it, but they've created a blockchain where you could change the data and you can't see the change. Now, the purists hate this. They basically say, this was one of the biggest reasons why we made blockchain. Now you can't really trust the data because maybe someone with authority changed it. The reason they came up with it is, what if, and this is actually a real example, my name is Michael McCarthy and I live in Boston. There was an infant that washed up on one of our Boston Harbor islands. They couldn't identify her for a few years. I think it was 2 years. Her name was Baby Jane Doe. And someone murdered her and just dumped this baby in the harbor. It turns out that the mother's boyfriend murdered the baby, and his name was Michael McCarthy. And this is true. Now, what if someone stuck on the blockchain that I was the guy that killed Baby Jane Doe? when I was teaching blockchain in China, someone actually raised their hand and said, "Are you the guy that killed the baby in Boston?" And of course I got red in the face. I'm like, what? What are you talking about? Well, if this was in the blockchain that said that, and I raised the alarm and say, hey, fix this. And they scratch it out. Okay, it said he killed the baby, but nah, that was another Michael McCarthy. Can you unsee that now? Can you not see me as the guy that was convicted of killing baby Jane Doe? And that was why the amendable blockchain came in, that you could edit it for things that you, quote unquote, couldn't unsee. And this is mostly used in the corporate world where they're not really as concerned with the purists. So blockchain continues to evolve, and basically it gets watered down by corporations for them to have their own personal use for it. Does this help answer your question?
Yeah, definitely. It's much clearer.
Okay,
Thank you.
great. And thank you for asking that, because this is, you can see once you get the basics, it starts to splinter off and get a little crazy pretty fast. Any other questions before I move on? Okay. So part of your project is actually also going to be using the business model canvas, which I believe most of you by now have probably seen a lot. This is just an interesting way for you to organize your applied project. And your applied project, oh, by the way, you will see on Canvas that there is an error in the description of the final project. The description that they have there now is from the Nano course final project. So you can disregard it. We will be fixing that. Basically, your applied project is going to be creating a blockchain startup, and I would like you to apply it to whatever your major is. So if you're doing, let's say, applied business analytics, bring business analytics into your startup idea that uses blockchain. If you really like IoT, bring IoT into blockchain. Blockchain startups don't have to stand on their own. They can, and I encourage you to mix them with other technologies. And feel free to raise a hand on that one if anyone has any questions. And basically, since everyone's going to be asking, your applied project is going to have 3 components to it. And again, we'll be putting this on Canvas, and apologies for not getting this right the first time. You'll be having a 5-minute video pitch, which will be under 5 minutes. So this will be your, basically your flashy commercial. Then you're going to have a 12-minute live presentation in front of a VC panel, kind of like Shark Tank. So I'll be on the panel, and the audience, which will be your cohorts, will also be on the panel, so they'll be able to ask questions. And we're going to ask you to have the business model canvas as a part of your presentation. So if you want to split these out into individual slides, you can do that. Also, the blockchain checklist is going to be a part of it. You don't have to actually use it, but you have to answer the content. I suggest you use it where you do little check boxes and say, yes, we got all 7. So you'll have the business model canvas. You're going to have the blockchain checklist. Then you're also going to do a SWOT analysis. So you're going to be talking about the strengths, weaknesses, opportunities, and threats of your project. And there's also a concept I created called DICE. And DICE stands for decrease, increase, create, and eliminate. Now what that does is you take a look at your SWOT, which is like a snapshot. And when you apply DICE to the SWOT, that allows you to get a better SWOT. So we're going to ask you to analyze yourself in the presentation. Say, here we've SWOTted our startup. And here we're going to DICE this. Now, the reason that I like DICE in a presentation is that if you talk about the negatives of your startup, it allows me to trust you more as an investor, because no startup idea is perfect. And if you tell me where the bodies are hidden, I can at least trust you better, because as a VC, I want you to do well. I want to do well financially when I invest in you, and I become your partner and mentor. So it's like a marriage. So we're actually going to have this startup to be like a friendly pitch where I'm trying to help you. And the more honest information I have, the better we can do. And then we're going to have 10 minutes of Q&A, and that's going to be open to myself as well as the class. And I'll be giving the class venture capital questions. These are typical questions that a VC will ask. How much cash do you need? Do you want to do an A round, B round, C round? How are you going to be spending the money? Basically the standard questions that you get from a VC. And so I would encourage everyone to be ready for that. And that's going to be a total of a 30-minute presentation all in. And I see Sanjit has a hand up. Hi, Sanjit. Hi.
Hi, how are you?
Good.
I just had a question regarding the dice thing. Could you elaborate on dice and how?
Sure. I'm going to put it, give me a second to put into the chat here what dice means so that everyone can take a peek here. It's going to be decrease.
Increase, create, eliminate.
Create and eliminate. And basically what this allows you to do is critique where you are so that you can get better. It just gives you a framework. And you will see that your first individual assignment is going to be swatting and dicing a blockchain project that you find off the internet. And there's millions of, well, not millions, but there's thousands of them that you can choose from.
Sure.
And you'll take an existing one, you'll swat it, and then you'll dice it. And the reason we do this is so that you can actually analyze a blockchain project, because a lot of them are scams, and you may be able to detect that. And a lot of them are using blockchain for the wrong reason, which is why I like to use the SWOT and the dice.
Okay.
Okay. Anything else, Sanjit?
No, good.
Okay. Let me just lower your hand here. Okay. So any questions before I move on to an applied project? Okay. Now I'm going to go slowly. So I know that for most of you, no one's gone through the material yet because this is our first day and they just opened the class up. So I'm going to go very slowly. If there's something that confuses you, please raise your hand so that I can stop and review it. So this is an actual project that I did in China with MIT and the Chinese government last summer. This is using blockchain in education. And could you all raise your hand if you have any familiarity with startups and startup pitches? So I see about 6 hands so far. Okay, so basically what we're trying to do here in a very simple format is identify a problem, use blockchain to be the solution, talk about how you make money at this, and then how you scale it. This is in a very, very basic framework. What's the problem? What is the solution? What's your market to make money at it? And how do you scale it? And let me just lower the hands so I can see fresh new hands that have questions. So this is a blockchain and education solution. So here's the problem, and this is actually real. This really happened. In China, they have problems with fake transcripts, fake diplomas, and fake college essays. What I'm going to do now is really expand the problem and show you just how many tentacles this problem really has beyond the obvious. So job applications, you'll see on the left, about 85% of them have something misleading in them, if not outright false. Annually, there are more fake PhD degrees than real ones. So this is a huge trust issue. When someone says, hey, I just got my PhD last year, probability would say, based on this data, that they probably bought it. And you'd have to ask, so where'd you go to school? Can I see your degree? And this is why having degrees and transcripts now are creating a trust problem. Just saying that you have these credentials doesn't necessarily mean that it's true. So the bigger problem that China is having, and by the way, China loves education. They have a huge respect for it. I was told that over 25% of Chinese families will spend a quarter of their income on their child getting a good education. So it's a really big deal. And it's an even bigger deal when honest Chinese students have applications that aren't trusted. So let's take a look at a specific example. If you applied for application at Harvard, it's about 20 people applying for one seat in the undergrad school. That's the Faculty of Arts and Sciences, FAS. So let's take a look at these three people. So we have an American, we have a German, and we have someone from China. And three of them qualify for a spot. So now put yourself in the position of being on the admissions committee at Harvard. You got 20 applications, 17 get rejection letters. 3, they all belong here. They're qualified. And it literally comes down to eeny, meeny, miny, mo, who I can't tell who's going to be successful out of these 3. And it becomes a really hard decision. Same way when you go on, like the Hult Prize. I'm one of the coaches for the finalists for the Hult Prize, and whenever we go to the UN, every year we get 6 startups, and all of them can do well. And Bill Clinton says every year, typically it's the group that got in 2nd or 3rd place that does better than the winner, because you don't really know at that point. So this is where it gets confusing. So now 3 out of 20 qualify. But then as the admissions officer, who are human beings, they are sitting here saying, wow, what if the Chinese application's fraudulent? I could get fired. Harvard would look bad. We're going to be giving a seat to someone that doesn't belong. What happens to the German woman or the American guy? They're going to feel defeated. They've gone to their second choice college. A lot of bigger problems happen to other people if we let in fraudulent people. So again, here's where the problem really gets magnified. Harvard's reputation could be trashed. That, CNN, a lot of media would love to say, oh, Harvard got duped by a fake application. So Harvard's reputation could be on the line. But then you get back to the human element of the admissions officer, that it might be safer just to not allow the Chinese application in because you're not really sure. And you're still left with 2 people that are totally qualified. So now you have a dilemma of 2 instead of a dilemma of 3. So is this discrimination and racism? It certainly brings that issue up. So that gets another problem that comes along with this. But look at all the losers who come in here. We just took a look at bottom left, the Ivy League or whatever college lets them in. They don't look very smart. On the top right, there are agents that will help Chinese students get into colleges. If they start having honest students not get in, then they're going to start losing business. So the problem is honest students being improperly tagged as fraudulent or questionable with the validity of their applications. And the other big losers is bottom right. I met a lot of these students in China. I gave speeches to about 15,000 students, and they work 12 hours a day. And it is completely unfair that they don't get into a college that they deserve to get into because an admissions officer has some doubt over the validity of the data. But now let's make the problem even bigger. And I'm spending a lot of time on this just so you can see why we're doing this project. The dangerous global trend is that Chinese students worldwide might not get accepted. There was actually a very large lawsuit against Harvard for this, not because of fraudulent applications, but basically for straight discrimination. But still, you could have a massive trend of Chinese students not being accepted worldwide. And if you want to multiply that out, that could actually hurt China and their GDP with global competition. So now it becomes a massive issue for the nation as a whole. But what if now we move into the solution? So section 1 of the startup is done. I spent a lot of time on the problem. So this problem is really worth solving. Now we move into the second component of the project is the solution. What if you could trust these applications? What if you could verify them? So all the student credentials were trusted and verified once they hit the admissions officer's desk. So now the admissions officer's back to the same dilemma. Which 3 do I choose? Well, now it's their problem, but at least you're not getting into racism, discrimination, making bad decisions, hurting reputations. So now when you see the words trust and verify, blockchain starts to bubble up in your consciousness. And here's what we could do. What if we could put transcripts, essays, and diplomas on a fancy database called blockchain, where it's going to be on multiple databases spread around the world. You can't change it, and appropriate people who have permission can take a look at it. So imagine that a student puts an application on the blockchain, and Harvard can look at it, Hult can look at it, Stanford can look at it, University of Michigan can look at it, and it's all the same information. And it's all been verified before it got on the blockchain. You will also notice that you can put bad information on the blockchain. You can put 2 + 2 = 5 on the blockchain. Blockchain, once it's there, it's written in stone, doesn't mean that it's right. So one problem that we're also going to have to take care of in the applied project and any blockchain project is making sure that the data is right before it gets on the blockchain. And that will be a sidebar discussion of how do you make sure that the report card that said the student got all A's really did it. Well, you're not going to want the student to put that data on there. You don't want the student's parents, but maybe if you have these schools in China hand in the report cards to a government agency, and the government agency says, hey, if this is fake or we find out that you got bribed for this, you're going to jail. There's some security there. And if a Chinese government agency verifies that this information goes onto the blockchain and they're the verifying agent, the one that puts it on there can be more trust in that. So here's how blockchain can help education on multiple levels. So one, this startup wants to store and deliver authentic diplomas and certificates onto the blockchain so that there can be fairness in deciding who gets into a college. So there's going to be 6 big advantages. The information is verified first by someone who is trusted, let's say a government agency, or maybe the school. Maybe you trust Hult to put your report card on the blockchain. Can they be bribed? Yes. Again, it's not a perfect world, so we want to make sure that we try to get that data as verified and accurate as possible. The data, once it's on there, is going to be permanent. So imagine that, let's say, Hult San Francisco moves to Hult Los Angeles and Hult San Francisco goes away. Well, your report card and transcripts don't go away because they're on the blockchain. And even if the school, no matter where it is, let's say goes bankrupt or closes or burns down, that data is still going to be there because it's permanent. Now, also the advantage is the student can control this data too. They can't change it, but they could send it to different colleges for applications. So imagine an app that says, yeah, I want to apply to 5 different colleges, just hit the little boxes and send it off, and I give approval for them to take a look at my information. This also makes it convenient when it's in an app form. Now the data is going to be trusted and secure because it went on the blockchain and was verified before it went on there. So this is what we did. We did a digital diploma partnership. So we reached out to MIT, and what MIT did is there is a private company that is owned by a guy that has a company called BlockCert. BlockCert's a private company, but he has a strong affiliation with MIT. And so he made digital diplomas on the blockchain. And Algor Block in the top right is the company in China that I worked for. This was the Chinese partner. And what we found is that if you're going to be doing business in China, you do need a local partner to do translations, to put these apps on WeChat, because if you had it on a Google platform, Google doesn't work in China. So there was a lot that the Chinese partnership added, and my job was basically to be the go-between. So there's 8 specific advantages of having digital diplomas and certificates. One is that now your paper is virtual instead of being in a physical format. So if it burns or floods, we've taken care of that problem. Number two, it's tamper-proof. So even you, the student, you can't change your grades. You can send them around, but you can't change anything. Number three is that now you can easily transfer credits to a new school. So instead of taking that big envelope that has all these signatures that were notarized and photocopies of everything, that's all gone. It's now been digitized. And the student, and this is one of the important things that blockchain can do, is that the student can control the diploma and certificate as much as the school can. For example, I had a friend from Iran who was trying to get into medical school in the United States. He couldn't get his transcript because the school in Iran never picked up the phone. And so he just couldn't get the transcripts. That will go away. In Puerto Rico, when they had the hurricane, a lot of records for teachers were lost, teacher certificates. And since that went away in the hurricane, they couldn't verify that they were actually teachers, even though they've been doing it for years. Number five is that now you can share this. So it can go beyond school applications. You can use it with employers. You could transfer to other schools if you want to get your PhD or get other degrees. Number six is now you're going to have a central location for all of your credentials. So if you went to 4 schools, you don't have to have 4 transcripts. It's all going to be in one nice pot on the blockchain for you. Number 7, which we've covered, and you'll notice I'm going to be repeating myself a lot so that this starts to sink in on the cellular level, that now it's safe. If you become a refugee, this happened in Syria. A lot of highly educated people came out of Syria who can't verify that, yeah, I'm a surgeon or I'm a lawyer, and that becomes an issue. So if you become a refugee or you're subject to fire or the school goes out of business, your data is still there. And number 8 is that it's going to save the college and student time and money. So the time and money that you spend applying to different colleges, mailing, calling, hey, did you get it? Can you send me my transcript? Oh, I got to pay for that. The transcript office, they don't have as much work to do. All the verification, imagine employers calling to say, hey, did this person really work at these 3 positions? It could save a lot of people who do manual verification a lot of time and money. But now watch how we start to scale the solution. So we've talked a lot about diplomas, college transcripts, and original college essays. But you could also copyright intellectual property. What if you made a patent during school? What if you get certificates and badges after you've graduated and now you're working at Google and they send you off to executive ed? What about professional licenses? What if you became certified as a lawyer or a doctor? Before we move on, take a look at original college essays. And here's the challenge. How do you know that my essay was real? So like, I'm going to just kind of look at David because I see him in my screen. So let's say that David's super smart and I'm not. And I go to David and I say, hey, I'll give you $500 to give me a college essay. And he does. Well, David's smarter than me, and he sold that same essay 200 times, and the 200 people don't get in because someone figured that one out. So when I put my original college essay on the blockchain, how can you verify that it really was mine? And think outside of blockchain, because blockchain might not be able to solve this. Raise your hand. So imagine I'm in China. I'm really trying to get into a college. How do you verify that that essay is mine? David.
Okay, well, this is actually something we've recently been working on, and it relates to kind of natural language processing. So where you see if you have enough written material of an individual, you can really start to kind of distinguish like macro trends, like for example, the frequency of usage of certain words or sentence structure, you know, or perhaps certain mistakes in grammar that are consistently made throughout the texts. So if then suddenly you submit a text that is kind of, yeah, on a fundamental level, very different, you know, for example, it uses a very different vocabulary, different sentence structure, longer paragraphs, whatever, then, you know, it stands out if you do enough kind of statistical analysis of their previous work. So I guess here you could kind of combine like innovations in natural language processing and text analytics to perhaps make it easier for the system to spot fraudulent submissions.
I love that. That's a better idea than the one that I actually came up with. I should have met you last summer. What we came up with, because we couldn't come up with anything better, was two solutions. And feel free to come up with a better idea on this. One was having a video essay where we would actually see the student talking, and so it would be like a verbal essay. The other was having them come into, let's say, a government agency where they had to use a government computer, and there would be a video on them actually watching them type it out. That's a bit low rent. It's kind of low tech, really. But that was the one solution that we came up with, because blockchain really couldn't figure that out. That's one challenge that you will have with blockchain, is it doesn't guarantee that the data is good. It just will guarantee that whatever you put there isn't going to change. And that's a lot different. So a tombstone that says 2 + 2 = 5 will stay on the blockchain forever. So I would encourage you to focus on making sure you have some safeguards in there to make sure that the data goes in properly in the beginning. Now we come into control. And this is another feature that blockchain has. I was talking to David about the public blockchain versus permission blockchain. So let's imagine that we're going to use Hult. So let's say that Hult San Francisco puts their diplomas on the Hult blockchain. Okay, well, that's a private school and they operate it. And we hope that they keep operating it for years and years and years. Now, what if we want to expand that? What if Hult makes a Hult diploma blockchain that has San Francisco and Boston and Dubai and London and Shanghai in it? Okay, well, we could go even further. What if we had a American blockchain diploma? Or what if we want to include Mexico and Canada, North American? You can go even further, make it a global depository. Maybe it's something that's overseen by the United Nations or some sort of global body that has everything in the world. But the beauty of what blockchain can do for you, and I encourage you to put this into your project because it's one of the great benefits, is that the student can control the data. So you could actually have all this information put on, let's say, the Hult global blockchain for diplomas, but then David and Bernice and Idris, you don't have to call up Hult anymore to get your transcripts. It's yours as well, and you can send that around. You don't have to call them anymore. And let's say that Hult goes away, or you move to Russia or wherever, you don't have to email or call anyone. It's on an app on your phone. So it's yours, your control. And that's one of the beauties of blockchain, that now people who are the origins of data can actually control it and perhaps sell it. So really the big goal that we were looking for was to have Chinese transcripts to be the most trusted in the world. So we wanted to flip it from being arguably to some the most untrusted and flip it to the absolute most trusted, and have them be really a gold standard for other countries to follow. And by the way, China loves their blockchain. They're all over it. And it was pretty exciting to be there for the summer. So now what we're going to do is we're going to dig. So now we've given you the idea. So on a high level, this is looking pretty good. But now we need to start to dig into some of the details of how do we actually execute this. And we're going to ask you to also do this in your project. So here is basically the team. So we have Learning Machine, which is basically a part of BlockCert. So it's basically, it's like a partnered company. So Learning Machine is the company, BlockCert is their product. So Learning Machine is the company, and BlockCert is the product that they sell. On the bottom right, you could effectively look at me as like the salesperson. I was pretty much the glue between everybody. And then top right was the Chinese partner that would do the translations, get the apps put on all the platforms, and also make all the connections with the government officials in China that would actually be able to promote this. So now what Learning Machine will do, and you can actually get this at Harvard and MIT and some other schools, is that now you get, on top of a paper diploma, you also get a digital diploma. So on the bottom right, you'll see there is a public key, and then there's a blockchain address. So the public key is kind of like my email address. It's almost like a Dropbox where anyone can have it. Hey, you want to send me some money? This is my account number. It's okay that the whole world has it. It's kind of like my email address. And the blockchain address is going to be the encrypted information that gives details about my diploma. And the interesting thing about this encrypted blockchain address is it doesn't allow you to go backwards and figure out what the diploma says. So that 4VF64, you can't use that to say that this person went to Harvard or MIT. Also, the way this address works in the encryption, and we'll take a look at this a little bit later, is if you changed one little thing, like maybe you took a small t and made it a capital T on the diploma, that blockchain address would completely change. So this thing doesn't tell you anything. Now, it's independently verifiable. So this is actually what the app really looks like. And you can download the BlockCerts app. Really won't tell you much unless you actually get a diploma, but they do have videos on YouTube that you can take a peek at. And they're like little 2-3 minute commercials. So the solution really is that we take the diploma, which would be on the left, or any piece of data, and it goes into a 64-digit hash, which is like a serial number. And all hashes are the same length, 64 digits. It's a combination of numbers and letters. So you could hash and encrypt War and Peace or a short poem, and it's still going to be 64 digits, which is why it doesn't really tell you anything. The interesting thing is you can take that same information on a different computer and hash it, and you'll come up with the same code. So you can go forwards and get the same code, but you can't go backwards and hack it the other way. And basically, here's the steps on how it's going to be working. Let me just minimize my window so I can walk you through this. So let's say that you graduate, and the issuer, Hult, is going to send you an email saying, hey, we want to give you your diploma. Number 2, you, the student, says, okay, great, that sounds really cool. And number 3 is that Hult will take your diploma and hash it, which just means encrypting it into the 64-digit code, and then they're going to send it to you. So you're basically going to get like this serial number, and that's going to sit on your phone, and now you can take it and you can send it anywhere you want. And number 6 is whoever wants to verify it, they download the app as well, and then they go backwards to BlockCerts, and BlockCerts says, yes, this is good, or no, this is not good. And that's basically how it works. It's relatively simple. And again, we will not be getting into coding. We're not going to dive too deeply into the programming at all. We're really going to be staying on the strategic level. So basically, it's kind of like I'm teaching you not how to build a car, but how you can use a car in a business for your advantage. So I can give you the basics of a car, and from that you can say, well, I want to make a bus, or I want to make a truck, or I want to make a golf cart. These are all basically strategic differences, but you don't actually have to build that different vehicle. And again, these are just some different slides on what the BlockCert app looks like. So these are just basically screenshots. And feel free to raise a hand if you have any questions. And again, these are just screenshots of what this actually looks like. And these are your diplomas. You just send them around. Rucha.
Yeah, hi. I have
Hi.
a quick question. So, is there a limitation on for how long can you save these documents in an encrypted format on blockchain, or is it like who decides that how long should the document? Because I think the requirement might change from use case to use case.
Well, basically, it's there forever, in parentheses, as long as that blockchain continues to operate. So for example, we talked about let's say that Hult San Francisco has their own private blockchain and they maintain it. So they have their IT department making sure everything's going okay. And let's say they decide to move to Los Angeles and they shut everything down. Well, they no longer maintain the blockchain. And that's the end of that. So what some people do is that they actually put their information on blockchains that they feel will last, quote unquote, for forever. And a lot of people are putting diplomas and information on the Ethereum blockchain because it's one of the most popular, it's one of the strongest, and people are putting diplomas and other information on the Ethereum blockchain, using it kind of like a record storage device, even though people aren't trading Ether on the Ethereum blockchain or using smart contracts. So they're kind of using it as a storage vault. And that's another issue that you may want to take a look at in your applied project is if you're putting data on the blockchain, which one are you going to put it on? And I'd encourage you as a default, and you'll learn more of this when you start to dig into the modules, that using the Ethereum blockchain is probably going to be your safest default bet. Maybe for some reason you want to have your own, like if you're a government, you might want to have your own. Does that help?
Yeah. So just to add on question on this. Now in this case, because we are talking about transcripts and documents which we might need lifelong, so it makes more sense to have them forever. But let's say if we are talking about some other industries such as pharmaceutical industry or food and beverages, where at some point the product or that ingredient might leave your supply chain and is eventually consumed by the customers. So in that case, would it still make sense to have these details still on the blockchain because the product has already left your system?
No, but it doesn't really cost you much to keep it there.
Okay, but what I was trying to understand is does it takes a lot of space, and in terms of storage, is it costly, not costly?
It's not very costly, and you bring up an interesting point that you'll dig into with the modules, that for the most part, blockchain doesn't really hold a lot of data. It holds receipts. So it would be holding, it wouldn't be holding, let's say, all of your it wouldn't be holding your actual diploma on the blockchain. It would be holding just the hash, just the receipt number that said, okay, this is Rucha's receipt for the diploma, but you wouldn't actually see the diploma itself. So really it's just storing a number. It's like a reference. It's kind of like a URL, that when I get the URL to, let's say, a YouTube video, I don't actually have the video, but I have the link to it. So you could look at it as links to more data, but typically they just put the link on the blockchain, but they don't actually put all the data.
Got it.
Okay. And to dig a little bit deeper, so let's say Rucha's in the food business, and let's say she's selling spices. And 20 years ago, they used to deal in cinnamon, and they had a filing cabinet full of cinnamon receipts. Okay. Well, now it's 20 years later, we don't deal in cinnamon, we don't really care. Well, you could get rid of that filing cabinet, or it could just be moved to the basement and you don't need it anymore. And it doesn't cost you anything just to have it sit there. Maybe for some reason you want to go back and look at cinnamon 20 years later, but that's basically what it is. It would just be an old record that you don't have to refer to, but it doesn't cost you much to have the filing cabinet in the basement. Same way it wouldn't cost you much just to keep that old receipt on the blockchain. Rodolfo.
Yes, now that we're talking about the security on blockchain and everything, I would like to know more about the input method itself. Like, how can we make sure that only the people that are authorized put the information on the blockchain?
Okay, I love the question because this comes down into another issue of vulnerability on the blockchain. That specific example, let's say that I work in the transcript department at Hult, and Rodolfo didn't do that well, but Rodolfo wanted to do better. So let's say you got a B out of the, when you graduated with a B, but you want to be graduated as valedictorian. And you come to me And I say, well, you got a B. That's what you're going to get. And you go, hey, Michael, here's $50,000. Why don't you change that? If I have the sole authority to change your data, and I can, I take the bribe, and we're done. So it's the same as putting 2 + 2 = 5 onto the blockchain. Now, if you want to get around that, and this will be part of your project, how do we make sure that the data is good going in? Maybe we change student records to be numbers, and maybe no one in Hult, San Francisco is allowed to handle transcripts. Maybe it would be, let's say, an outside firm, and we've got maybe a techie firm in India, maybe we have a techie firm in Russia and a techie firm in California. And we basically say, okay, we're going to make a transcript for diploma 125, and here's the grade. BBB, and maybe Rodolfo could find, you're not going to have easy access to these 3 people because no one's going to tell you who they are, but let's say that you find the person in California, they'll take the bribe and they'll give you an A, but then the other 2 people would say, hey, this needs to be, the 3 letters have to equal, B must equal B, must equal B, but this is ABB, something's wrong and it won't get verified. So the way around it is to have people that don't care, don't have any interest in this data being a B or an A. You can't find them, and they have to match up. So this is where you get into finding people that do not have an incentive to be dishonest. And that's going to come down into your individual project. One issue that you could have is, what if it's a medical blockchain and it's medical records, and I'm a surgeon. Rodolfo came to me and I made a mistake on a procedure and he passed away. What if I just put in the records, natural causes? What if I give money to the medical examiner because I know who they are? So I'm really not, as the doctor, the one that's providing these medical services, I shouldn't have permission to verify what I did to a patient. Someone should be overseeing me who I can't get to. And this is where it does start to get tricky, because if you put in bad information, it's just going to be bad information for forever. So this is where you're usually looking for strangers or people that don't have any interest. And permission blockchains lend themselves to this. You know, Bank of America, they have a blockchain, and they probably only want Bank of America employees to put information in. So that might not be terribly trusted. What if they committed a fraud? Do they really want to have the correct information on the blockchain? So this is where it starts to get fuzzy, because corporations are coming into this and things start to get messy pretty fast. Does that make sense for you, Rodolfo?
Yes. Yeah, that was make perfect sense. But also, so you would recommend, when a company is starting to implement this system, to also have a non-blockchain way, so maybe have a redundant system as well to make sure that it's correct at first?
You could have something outside of blockchain that would be verification. That would be up to you, yeah, and feel free to be creative about that. But that can be one of the challenges. How do we know that the data going in is right to begin with? You would have the same issue with, let's say that a Chinese government is, or just any government, just to make it benign. Now the government is holding, all these diplomas, and what if your dad did a scandal, or there's some problem and the government doesn't like your family anymore? Could we just zap your diploma? Well, yeah, so now you're not necessarily trusting the people that you were supposed to be trusting. And this is where having outside people doing it on your behalf. So probably outsourcing it might be a safe idea. Feel free to raise other hands as I just go through this. So again, you can see, you can put college essays on here, letters of recommendation. Now we're going to start to get into other uses, and this is where you can start to expand the startup idea into different markets. So let's say that this is Jennifer, and Jennifer already graduated Hult, and now she's a medical lab tech, and this is really interesting. So now that she doesn't care about her diploma anymore, she already graduated. She has a job, but she can put postgraduate work on there. And since she controls it, anything that she accomplished on the left, those little certificates, could be postgraduate work, goes into her certificate wallet, and she can decide what she wants to put on LinkedIn, who she wants to send around to new employers. She could put it on Dropbox for her own external storage in case the Ethereum blockchain, she doesn't think that's going to go forever. Now look at all the clients that we could have with this startup. So again, we're back to verifying on the blockchain. So students would want to give me their diplomas. Agents, they would want to hire me because I could say, I can take all of your student data as an agent, put it on the blockchain. You can charge an extra fee for that. And now you stay in business so you can make sure that your honest students get where they're going. Universities would want to pay for this because they would rather pay for pre-verified applications instead of trying to call around and make sure this information is good. If you're looking for a job, an employer is going to want to take a look at this, like, hey, you're blockchain certified applicant. If you're looking for a job as a professional, human resources, remember 85% of the applications they get have something funny on them. So they might want to have blockchain certified. And then outside data purchasers might want to buy some of this very rich data. And this is where you, as the student, the original client, could actually make some money. So let's dig into each client. So the student, obviously, they want to pay for this so they can get into a good school. The agents, they want to have their information from their student clients verified so that they can make sure that they get in. Universities, they don't want to look silly by letting in the wrong people, so they might spend money on making sure that they get verified data. Also, they would spend money on verifying diplomas because they don't want to be handing out diplomas that can also be copied. Again, once you've graduated, you're still going to be our customer because now you want to take that verified diploma and send that around to get a job. If you're a job-seeking professional client, anything you've done postgraduate work, all the companies you worked for, you could also verify that as well, that yeah, you really did work at Google, you really were a senior VP. Human resources, this could save them a ton by making sure that they're only going to be getting verified data so that they can then make their decisions and make sure that they're hiring the right people. Here's where it gets really interesting. This is what I like, is outside data sales. So imagine that I own this blockchain, it's my company, and I am going to try to sell, let's say Amazon or mattress companies or whoever might want to be interested in all this rich data. I could sell this data to them with a smart contract, which is basically just a digital form of a regular contract. And the interesting part is that you, the student, you can earn money. So I can now be your broker. So I could go to, again, I keep calling him David because I can see his screen. So David was my client for years. He went through Hult, and then he had a couple jobs at Google. And now if someone wants to know all this stuff about David, I could go to him and say, David, I got some guy that's going to pay us $1 million for our database, for pieces of it. I'll give you a 15% commission if you let us release some of your demographic data. And here's what they're asking. Would you like to get paid for this? And David can say yes, or he can say no. If he says yes, I sell it and give him a commission check. If he says no, I don't do it because David owns the data. I don't have permission to sell his data without him knowing about it. And then here's one just quick shot of all the revenue streams that we have. So we actually have seven revenue streams in this startup. And I've already gone through all these people, but this is just basically like one little quick shot of 7 ways that I can make money with this idea. And then here again is the partnership team, the Chinese government, myself, basically the networking glue. The tech is coming from BlockCerts, Learning Machine, and then Algor Block is the Chinese partner. So the Chinese government, they certainly want to promote this because it makes them look good. It helps out their country. Algor Block, of course, they want to do business with Americans and they want to have a viable business model, and they provide a service that you can't get anywhere else. And then I'm happy to do this because I like to travel and I have a lot of fun in China. MIT, they want to become the gold standard for digital diplomas. And that was basically our startup. That was it. And these are some other resources that you can take a look at. You can screenshot that. And feel free to raise a hand if you have any questions or comments on how this project went about. And yeah, these are just other screenshots that we don't need. Okay, so I'm going to stop. I'm going to stop sharing my screen, so I'll get rid of the slides. But raise your hand if you want me to refer to the slides for anything. Am I saying your name right? Ugur? U-G-U-R? Hi. How do I pronounce your name? I'm not hearing you, and I'm not seeing your mic moving. I see it's unmuted. Would you like to put that in the chat? And Precious. Hi, Precious.
Can you hear me?
Yes, hi.
Perfect. I was just curious because in our previous courses, they've spoken about the whole issue of like data breaching, and now there's like GDPR in place to help, consumers have kind of authority over their data and who can access their data. So do you think like blockchain will basically have a positive effect in that sense where, you have access to your data and you have, authority as to who you want to give access to? Or do you think blockchain, there will also be some type of, I guess, restriction or issue on, data? I know we said it's decentralized where, there will be, our information will be in several places, which makes it harder for hackers. So I'm guessing blockchain will be a positive effect in that sense, right? In the case of this whole GDPR that is being placed in effect now, and how it will also affect companies and consumers.
Correct. As far as the control of the data, when you get, so this project was a private company, and it was a permissioned blockchain. And the governance was, we wanted to give people the ability to send their data around as they wished. And we, from the outset, our personal governance was that we're never going to sell Precious's data without her permission.
Okay.
So that was our agreement, that we would not do that. That if we did do it, it would be with your permission and we would give you a commission on it.
Okay.
So you would have to look at the individual blockchain company and see what are they designing to do.
Gotcha. Okay. That makes sense. Thank you.
Sure. And then Ugur put into the chat, is it going to be a group or individual project? You're going to have, the answer is yes to both. So your individual project is to take a look at an existing blockchain idea. There's plenty of them you can Google around. I would stick with what your interests are, the industries that you like. And when you go through the course, you'll start to see things that resonate with you. And you will SWOT and dice a startup, and that will be your individual project. The group project is going to be the 30-minute presentation where you're going to be giving a startup pitch in person in San Francisco that has the 3 components: a video pitch that's under 5 minutes, a 12-minute live presentation that will include the business model canvas, a SWOT and dice, and then the blockchain checklist, and then 10 minutes of Q&A, which are going to be pretty much your standard venture capital questions. But I would really encourage you to do projects that are of interest to you in industries that you like, that also fit with your major. So you can actually you can mix things. So if you're really focused on IoT, then you can also bring IoT into blockchain easily. Okay. So we've got about 10 minutes left in class, which I left open so that we could do any Q&A, talk about where you're confused, because usually there is some confusion. I really love all the questions that have been asked. These have all been like really, really good questions. And I'd love to hear some more. And look, Yuyan, is that how I say your name?
Oh, yes, Yun. Yeah.
Hi, how are you?
I'm good. How are you?
So you have a question?
No. Yeah, I think it's enough information I got. Yeah.
Okay. And then I also see Yu Yan, Yuyan. Am I saying your name right? I see your hand is up.
Yep. You Yan. Okay.
Yeah, Yu Yan Mao. So now, why don't I go to Albion? Albion, I see your hand is up.
Hi. I want to ask, like, which industries has blockchain struggled in entering? Is it because of regulations or like limitations of the technology?
Well, it struggled in a lot of them. I will tell you the low-hanging. I'll answer the opposite of where it's doing well. Is it's become very popular with banks to wire money with smartphones. So that's one. Electronic medical records has been another. That's more in smaller countries because larger countries like the United States, they have sunk legacy costs. They spend so much money on existing systems. They don't want to spend money on something new. But you can go to smaller countries and they're more interested in it. Also, food traceability in the United States, Walmart's using it. We actually have a video in the program about how they're doing it. So I would say food traceability, identification is also a big one. In Jordan, there's a refugee camp that does use blockchain where the money they give you to buy food is through retina scan. So you don't actually have to carry a wallet or identification. You just have your eye scan and you can buy your food. So that's where it's going well. Where it is struggling, one that I know, we had a student in our Harvard class, he worked for an energy company, and it's very popular for people to have some excess solar energy. So let's say Precious has a windmill in her backyard, and she's got some solar panels. She has a small house, and one day it was super sunny day, and she doesn't need all the energy. So she wants to sell it back to the grid. Well, everyone got all excited about that everyone can now become energy producers and make some money. Problem with the energy companies is they have to make the technology to allow you onto the grid. And I was told sort of off the record, they don't want to do that. And they're going to use national security as an issue that they don't want to have anyone being able to get close to the grid to cause trouble. So they'll just like raise the Homeland Security terrorism flag. So energy, I think, is going to have a really hard time getting on the blockchain. There's also the question of how much energy could one or two houses really sell back to the grid. So that's one that sounded really good, but in reality, they're having some serious problems with it. There are different ways to slice, energy up besides just selling back to the grid. But that's one of them where there's a challenge. But you may want to take a look at where people are already having success and maybe twisting it or maybe creating a new industry out of it. Also, blockchain doesn't do very many transactions quickly, so it can't do credit card transactions right now. It's too slow. But it could do things like record birth certificates because there's not a lot of transactions there. Does that help?
Yes, thank you very much.
Sure. And Rucha, hi.
Hi. I was just going through the remaining slides, the PDF that was uploaded on my courses. And on the last slide, there's a machine architecture which shows that how different layers are interacting with each other and where the blockchain fits in. It's slide number 78. Could you just talk some more on that architecture, that how the data is flowing and which entity represents which layer in that machine architecture? And also I would love to know that if I want to use some sort of analytical tool to gauge how things are performing with the blockchain in the picture, where would that component fit in as part of the architecture? Like which entity will be responsible for that and how will they do it?
Could you repeat that again? I was just pulling up the slide you were referring to, so I was kind of multitasking. Could you say that one more time?
Yeah. So my first question is on slide 78. It's good to see the different architectural components that get involved as part of the blockchain process and where that exactly fits in. If you could throw some more light on which entity represents who. For example, the first box which says certificates, app, and service layer. So I'm assuming that when it says web app, is it for in the startup that we just discussed, will it be students who will be the acting component through the web app who will raise the request that I would want to place my documents on the blockchain, and then comes the internal service and what does the foundation layer do. Like, I'm just requesting you to like walk us through those steps to understand like which entity comes in where as part of their role.
Okay, so I'll walk you through, and also I'm going to be more focused on the idea and the strategy as opposed to this part, which is basically like lifting up the hood of the car and kind of digging into the engine. So don't get worried if you're looking at this thing being like, oh my God, I have to figure all this stuff out. What you will be able to do if you kind of want to punt this a little bit is you could say that we're going to be working with Linux Foundation or IBM, and they're going to be walking us through the back end of this, that our startup is going to be the front end, and we're going to hire consultants to do all this back end stuff. So that is okay to do, but I'll walk you through pretty much what this looks like. So so let's say we take a look here where we've got an app, and so you've got the web app, which is going to be the first little blue box, and this is going to be using cloud services, and they're also going to be using Linux. So this is using the Hyperledger blockchain. So there's different kinds of blockchains, and you'll be noticing those when you get into the data that you need to pick a kind of blockchain that you're going to use. A lot of people like to use Hyperledger, and the reason is that it's kind of like a plug and play, and it has smart contracts. So if you want your blockchain to actually do transactions with people, like you could have a landlord renting apartments to people. So the smart contract would be, let's say, the rental agreement, and then the blockchain could also keep track of the payments. So the payments could come to the blockchain. It could track their payment schedule so that they could get like a credit score, and you could help them with that credit score so they could actually get credit on financing outside if they don't actually have a credit card. So all you really need to do is just talk about which blockchain you want to use. But a lot of people are Hyperledger Fabric. You'll see when you get into this, it's almost like a one size fits all. But when you dig into it, you might have some more special things that you want to have in here. But a lot of this is just basically the servers and the nodes. It's a lot of just the back office part, which really is not the major focus of how the class is going to operate. If you want to dig into this, you're welcome to, but all we really ask you to do is just tell us which blockchain you want to use, and you'll see the choices that you have. Does that help?
So we will be covering that, like at least for us to be able to decide that which type of blockchain we want to use for our applied project. You will provide some more details in the next webinar.
Yes, it's actually on Canvas. It is one of the modules, and it's really not, there aren't that many choices. You basically you can have a blockchain that's specifically for mobile devices. You can have a blockchain that also is really dedicated towards having smart contracts, if you want to have smart contracts on there. You have another one where you would be able to edit the data. Let's say you're putting on legal information, and let's say a court could possibly court order you in whatever business you're in that you need to actually change the records. Let's say someone changed their name, or maybe there was a mistake and you said that someone was dead and they weren't. They would need you, if a court's going to say, in our business, we're going to be required to change the data, then you would have to go with a blockchain where you could edit the data as opposed to just append it. So you'll start to see as you come up with your startup idea, it's going to dictate pretty easily which blockchain you want to use. But you really have like a choice of kind of like basically three. There's a few out there, but they're not. There's not that many differences when you really dig into it. A lot of them you could use one, and the other one would work just fine for you. But again, the focus is going to be mostly on strategy in this class. But we do cover the differences in each blockchain. Does that help?
Yeah, thank you.
And then Yuhyun Mao has an audio problem. Just wondering, have you got the question on why do I need blockchain in terms of the business. In your case, because students will be asked to have diplomas certified for U.S. college education. So what's the benefit of having a blockchain? Basically, you want to use a blockchain if you're going to be doing business with people who you don't trust, that maybe there's some incentive for people not to tell the truth. That's basically what it comes to. If everyone was honest and trustworthy and everyone said the truth, then you really wouldn't need a blockchain. So it's really coming down to having people on there who you might not trust their motives, as well as the security part of, we want to make sure that we don't get hacked or there's a hurricane event and really important information gets zapped. So making sure that the data is always going to be there and not necessarily trusting your participants are two big reasons why to use it. And Precious, I see your hand is up. Also, it is at 1:30, so class is officially over. So now I'll just move into office hours. So if you need to go to another class, we're done. I'm going to keep the recorder on if you want to watch this later. But now we're basically outside of class time and into office hours. So thank you all for coming. Let me put in here my email and cell phone if anyone has any questions. And I'm also going to put in another email address that if you want to put in attachments or send me something, that will work. So that's actually a really good email to get to me quickly. And Precious, hi.
Hi, I'm just curious. How do you think blockchain is going to disrupt the what's it called? The credit score? I don't know, FICO score. I don't know. It's not really an industry, but it's more like a, I don't know, company or organization as it is. Especially like knowing with the data breach that just happened. And individuals honestly not understanding the whole process of like how the whole FICO score works. Because I mean, I myself, I genuinely don't understand how it works. How do you come up with the numbers? Why do I get a 700 or I don't know, a 600 and someone else gets an 8? You get what I mean? So I'm just curious from your perspective, how do you think the blockchain industry is going to help, in situations such as those? Because I mean,
Yeah,
go on.
there is an app. I have it on my phone. It's called CreditWise.
Mm-hmm.
I have an account at Capital One. Do they have Capital One in San Francisco?
I don't know. I've not really checked.
It's basically it's an e-bank, and so I have this little app called CreditWise. It tells me what my credit score is, and when I open it up, it will actually give me the components, and it will tell me if I'm good or bad. Let me just pull it up so you can I can give you specifics. So it has my credit summary, and it says that it's looking at 6 components. So on-time payment, my oldest credit line, my credit used, recent inquiries, new accounts, and available credit. And then it will tell me if I'm at excellent, that's great. But let's say I'm going to do credit used, it says, is average. And it actually digs down that if you're below average, it's because you're using over 60% of your credit. If you're average, it's because you're using 31% of your credit, and that's what I'm doing. If you're good, you're using 11%, and if you're excellent, you're using 0 to 10. Now, mine moves around because my credit cards are on auto pay, so it just moves to the end of the month. So if the balance could be really high, I could have a high balance for a whole month, but then it pays it. So it bumps me, it actually lowered me to average because I used to just pay it like every week because I wanted the excellent, but the auto pay dropped me. So this is telling me how they're looking at me. So this informed me where I could say, oh, if I want to raise my credit score, stop using auto pay and just remind myself to pay it every week.
Gotcha.
So what you could do with blockchain, you actually don't need a blockchain for this, but you could use one. It would work. I just don't think that you need it because you could do it with other things. You could give people a transparent credit agency where you let people know how is the score calculated, how can you improve it, maybe get alerts that say, hey, you just kind of dropped because of this little thing you did. Do you want to change something? It could maybe make it really easy to make appeals if someone put something on that was like wrong, like maybe they took your name, there's another Precious that defaulted on something, and you're like, I don't even own a car, and I don't own a house in Peru. Like, what are you doing? And so they could make like an easy appeals button, because you can't do that, but they don't make it easy to do that.
Gotcha. That makes sense.
So I would say you can do it, but you don't necessarily need blockchain to do that.
Gotcha.
Okay?
Thank you.
Sure. Idris, I see you have a hand up.
Hey.
Hi.
So you might have referred to that in the beginning, but I might have missed you since I couldn't hear you right at the beginning. My question is basically, are there any sources or books you would like to recommend us in order to get a broader understanding of the whole topic of blockchain?
Everything is on Canvas. However, I will type in the Bible book. It's called Blockchain Revolution, and the author is Tapscott. It's very long. It's 400 pages, but it's really good.
All right. Thank you. Appreciate that.
Yeah, sure. He's also done some very nice TED Talks and YouTube videos, so you might be able to just kind of shortcut it by looking at those.
Yeah.
Yeah.
Sure. Thank you.
Oh, and it's Don Tapscott. Okay. Anybody else? Going once, going twice. Okay. Thanks for being in class today. Please reach out to me. My job is to make sure that you all do really well. And thank you for asking so many questions. They were great. And again, I will see you in a couple of days for the next thing. But again, reach out to me if you need anything. Take care, everybody.